Okay, hello. So today we'll learn about two Excel commands, norm.s.dist and norm.s.inv. Ignore ignore this. I just tested some of the stuff. So norm.s.dist as in standard normal distribution and standard normal distributions inverted value. So if I type norm.s.dist, it's asking me for a z-score and a cumulative, whether it's cumulative or not. So let's check one of our examples from lecture 8. This is lecture 8, and we have this question where we have the z-score 1.5, and we would like to see if the probability of z is bigger than 1.5. To give you a little more context, we want to see if the distribution is normal with mean 400 and standard deviation 60, and we take random sample of 36 observation from the population, what proportion of sample means will be greater than 415. Now, since we are asking sample means and not the random variable itself, so we converted the standard deviation from the raw standard deviation of that particular variable to the standard deviation of sample means. And we use this formula to calculate the standard deviation of the sample means. So the scores we have, the z-score we have, how do we calculate that? Is 415, that's in the bottom right corner, 415 minus 400 over 10. In Excel, you can do this. Let's say here, 415 minus 400, the mean, and I have to open and close the parentheses. And then we divide this by 10, that's the standard deviation of the mean. We get 1.5. So now what I'm going to do, I can use this 1.5 to check the probability of having the probability of the area left to this point, 1.5. This is 1.5. So probability of the area to the left, left of Z1. And if you look at this standard normal distribution table, you see 1.5 gives us the probability 0.9332. So since it's 1.50, the second decimal point is shown on the column. The up to the first decimal point is shown on the row. Okay, so how can we do this using Excel? We have this 1.5 from z-score. We use equal sign, then norm.s.dist, and then it asks for a z-score, so 1.5. And is it cumulative? Yes, it's cumulative, so I'm going to write true, then parenthesis close, and then press enter. So this gives us the same value, 0.933193, that's in our standard normal distribution table. So again, for 1.5 z-score, we have the area equals to 0.9332. Thus, the area left to the z-score of z1 equals to 1.5. That means out of the whole probability 1, we have about 93% probability of having a value lower than z1 or 1.5. Okay, and to get the value, the probability beyond that value, you have to subtract this probability 0.9332 from 1. And we have covered this in class. So the bottom line is you use this command norm.s.dist when you have z-score and you try to find the probability. So like this, you have z-score and you try to find the probability. You can do the other way as well. So you have the probability, but you try to find the z-score. There are some questions in the midterm and also in your book that requires this. So you have the probability 0.9332 and you'd like to find the z-score. How do we do that? We use norm.s.inv command. So let's try that. norm.s.inv, inv as in inverted. So what we are doing is invert. So I'm gonna type in 0.933193. That's our probability that we just received. When I press enter, it gives us this 1.5 back. Okay, so again, if I use this table, then 0.9332, if I enter 0.9332 probability, 0.9332, and press enter, I'm gonna get the same 1.5 value back. Ignore the little, like very little values here, because once you round it up until 4 decimal points, then they becomes very negligible. And since they are coming from a function and integration, which we showed in one of the lectures, the probability, the cumulative probability formula, and that's why it's making a slight difference when you move from one point to another. Okay, I hope this helps. Let me know if you have any questions or confusions. Thank you so much.